Dear students, we have already given some notes, handwritten materials on carbonyl compounds. You have got it. So in the first page of the notes, we have given the nomenclature of carbonyl compounds. Regarding nomenclature of carbonyl compounds, you have seen that Al is added for aldehyde, replacing the final E of the corresponding alkane. Accordingly, for ketone, the final E of alkane is replaced with ONE. So that means propanon, ethanon, etc. Now there is no ethanon, ethanol. When it is aldehyde, you know these things are done in your high secondary classes. Okay. We have given number of examples. Aromatic aldehydes, benzaldehyde is also given. You've seen cyclohexane carbonyl. When it is CHO, the CHO actually formyl group, and when it is not an aromatic compound, we can name the functional group as carbonyl, cyclohexane carbonyl. Again, in the lower part of the page number 1, you have seen that carbonyl group is on the second carbon, whereas the double bond is in the first carbon from the right side. But the numbering is done from carbonyl group side, that is functional group carbonyl is getting more preference over the double bond. Hence, the numbering is done from the carbonyl side. Hence, the name is pent 4 in 2 on. Okay. Again, acetohenone, it is a common name. Okay. Then we can name it 1-phenyl ethanol or methyl phenyl ketone. Okay. In the second page also, we have given some examples. Then in the second page, you have seen physical properties of aldehydes and ketones, which are compared with alkanes and alcohols. Alcohols are having higher boiling point due to the hydrogen bonding. You know it. You have got in higher secondary. Then acetone, then propanol, then butane. Number of carbons are same in all these compounds, but functional groups are different. Solubility. Regarding solubility, you have seen that where there is possibility of hydrogen bonding, the compound will be more soluble in water or aqueous medium. Although higher members are less soluble, because in higher members of aldehydes and ketones, in any organic compounds, higher members have more carbon, more the number of carbons. That means this more the number of carbons of the chain, longer the chain, the hydrophobic character is more hydrophobic. Okay, that means these are less soluble when the chain length is longer. Again, some in the page number 3, we have given some examples along with IUPAC's name. First one, you have seen ethane diol, 2 carbons, hence it is ethane. But here the E of ethane is not omitted, because di, D is there. After E, it is D. If it is ethanol, we have to be omitted the final E of the alkane. But here, since it is diol, then again 3-methyl butanol. These are very simple example. Pent 3 in L. We have counted from the right side. You open up the notes I have given, and it will be better if you print out the materials already I have sent in Google Classroom. We have given some compounds having both CO group as well as CHO group. When there is a CO group, when it is substituent, then we call it as oxo. As for example, here it is pentan 4-oxo. In the fourth carbon, CO group is there, 4-oxo 1L, or we can also say 4-oxopentanal. Then in the same page, we have discussed the synthesis of aldehydes from alcohol. This is actually oxidation. When alcohols are oxidized, it may give you aldehyde. Okay. When it is primary alcohol, it will give you aldehyde. Secondary alcohol will give you ketone, and so on. PCC, it is written, pyridinium chlorochromate is a very good utilizable oxidizing agent. Then again, we have given Swan oxidation. When it is Swan oxidation, it is Swan oxidation when dimethyl sulfoxide along with oxalyl chloride in presence of a base such as triethylamine is used, then it is called Swan oxidation. Here also we have seen that a primary alcohol is oxidized to aldehyde. Then in a second synthesis, we have given example of an preparation of aldehyde from acid chloride. You have got it in higher secondary also. Palladium barium sulfate, Rosenman reaction. This and catalyst is known as Lindlar's catalyst. When acid chloride is reduced with Lindlar's catalyst, then the reaction is known as Rosenman reduction. Aldehyde is prepared. Again, ester can also be converted into aldehyde by using dibel. This is called diisobutyl aluminium hydride. This is a good reducing agent. This is reducing agent. Okay. Then third is in the ozonolysis. You have got when alkenes are ozonolized, then either aldehyde or ketones can be produced. So here in ozonization, you have seen that DMS or dimethyl sulfide is added, so that one of the oxygen from ozone is removed away. The other two oxygen is get attached with the double bond. Okay, you have seen that double bond is broken, and one part give you one carbonyl compounds, the other part will give you another carbonyl compounds. Okay. Then in the page number 5, we have prepared synthesis of aldehydes from carboxylic acids. You have seen that manganese dioxide is used as catalyst at high temperature. When formic acid is used alone, you will get formaldehyde. When acetic acid and formic acid mixture is added in presence of manganese oxide, then acetaldehyde is produced. When benzoic acid and formic acid is mixed, then benzaldehyde is produced. Again, by distillation of calcium salt of acid, we have seen that calcium salt of acid also prepared. You know that sodium salt, potassium salt, calcium salt, these are sodium, potassium are um, sodium, potassium, these are monovalent. Calcium is divalent. So therefore 2HCO group, format group is attached with the calcium. When it is distilled, you will get formaldehyde. When calcium acetate and calcium format mixture is distilled, that means heated, and then distillation is taken place, then acetaldehyde is formed. Then again, number 5 in the same page number 5, synthesis of carbonyl compounds from alkynes. So alkynes, when treated with tetrahydrofuran, boron triborane, actually BH3, in presence of tetrahydrofuran, which acts as solvent, we will get trialkynyl borane. You have seen that in the middle CH3 CH11 CH whole 3B. This is called trialkynyl borane, which on oxidation in presence of hydrogen peroxide and potassium hydroxide, you will get this alkynol. Okay, double bond is there, and which group is there? Alkynol. Okay, then this undergoes tautomerism, where one of the hydrogen from the OH group moves to carbon, and you will get CH3 CH2 CHO. That means aldehyde is produced. Again, when acetylene is treated with sulfuric acid and mercuric sulfate, then you will get this ethanol, again tautomerizes to acetaldehyde. Okay. So in the next page, in the page number 6, synthesis of ketones by ozonolysis, same procedure as you have got in the last page. Then aromatic aldehydes or ketones can be produced by Friedel-Crafts reaction. This is benzene and acetyl chloride in presence of Lewis acid. Lewis acid, you know, aluminum chloride, ferric chloride, these are Lewis acid catalysts. When this is actually electrophilic aromatic substitution reaction to give you aromatic ketone. Similarly, when benzene is treated with benzoyl chloride in presence of aluminum chloride, then also you will get aromatic ketone, benzophenone. Again, from secondary alcohols, we have told that when secondary alcohol is oxidized, ketone is formed. When primary alcohol is oxidized, aldehyde is formed. Okay. Here also you have seen this DMSO, dimethyl sulfoxide, oxalyl chloride, and a base triethylamine is used to form secondary alcohol to ketone. Then this pyridinium chlorochromate has very good utilization when there is a double bond, again OH group. Then if you use strong oxidizing agent, what will happen? The both hydroxyl as well as double bond will also be oxidized. So if you require, say, double bond should be intact, then what will you use? We will use pyridinium chlorochromate in dichloromethane. This dichloromethane is acting as solvent. So only OH group is oxidized to CO group. Double bond remains as it was. Okay. Then another, in the page number 7, synthesis of ketone from nitriles. You know that this is R-MgX, which is Grignard reagent. When Grignard reagent react with an nitrile, you know, CN, when CN group is there with alkyl group, this is called nitrile. Cyanide is also called nitrile. Then you have seen this is a nucleophilic addition reaction. Then you have got RC double bond and MgX. R dash actually here in the Grignard reagent, alkyl group act as the nucleophile, whereas MgX